Okay, second how-to is looking at the second part of this question, which is to calculate the centroids of the centroid coordinates of our plate. So the first thing we're going to do is we need to look at the shape in particular, and we need to look up in our engineering formula booklets how to calculate the centroid of a semicircle, because we have two shapes. One is a semicircle, one is a rectangle. Now from our formula booklet we can see that the centroid of a semicircle lies along the axis of symmetry, and it is 4r over 3 pi from the base. So we're going to write down our centroid coordinates. As our first step, we're going to figure these out. So here it's going to be, for our rectangle, it is going to lie along the centre, the axes of symmetry. So it's going to be bang in the centre. That is going to be 60 along and 20 up. For our semicircle, it is already 40 up. The easiest one first is we look at it. The radius here is 50, which means it's 50 to here and 50 to here. So its x coordinate is going to be 50. The y coordinate, it is already 40 in the air, plus the 4 times the radius over 3 pi. So that is 4 plus 4 times 50 over 3 pi. So we put that into a calculator and we find out what it is. So that is 50 and 61.22. Then, in our working space, we are going to set ourselves up a table. So it needs the shape, we need the area, we need the x centroid coordinate, the y centroid coordinate, we need the area times the x centroid and the area times the y centroid. So our first shape is going to be the rectangle. The area of our rectangle, it is 120 by 40. So that is going to be 4,800. The x centroid we've just found, it is 60. The y centroid is 20. Now, this next step is we take the area and we times it by the x. So we've got 4,800 times 60. We get 288,000. Then we take the y, the area, and times it by the y centroid. So our area is 4,800. We're timesing by 20. So that is 96,000. Then we've done our first shape. We're doing our second shape, which is the semicircle. We find the area of our semicircle. So the area of one circle is pi r squared. So the area of half a circle is pi r squared over 2. So that's going to be pi times 50 squared divided by 2, which is 1250 times pi. It's sometimes smarter to leave things in terms of pi where possible, because it saves you typing out many numbers into your calculator. Right, second thing, we already found our x coordinates, so we would get 50 is the x coordinate, and our y coordinate was 61.22. Then we do the same thing, we take the area, times it by the x coordinate, then we take the area and times it by the y coordinate to go in this box. Then we are done. In terms of marks, we have 1 already. Out of 5 marks, we have already got 2 marks for getting the areas and the centroids for our 2 shapes. Our third mark comes from the overall method we have used. We're using the table method, so having our table with the totals at the bottom would have got us our third mark. So let's look at this. We need the total area, the total of our AI xi's, and the total of our AI yi's. Total area here, we're going to add them together. Which is 8,726.99. Here find it is 484,349.54. Then our total AI xi's is going to be 96,000 plus 76525 times pi, which is 336,410.378. Now, what gets us our last 2 marks is actually using our centroid coordinate formula to find the centroids. So our x coordinate is the sigma AI xi over sigma AI. So that tells us it is this big number, 484,349.54 divided by the total area, which is going to be 55.5 millimeters. Y. Our Y centroid is exactly the same thing, apart from rather than X here we have the Y's, because it is this number here. Put that into our calculator, we find that that is 38.5 millimeters. We could leave it here, or we could write our centroid coordinate as a coordinate, which we would do by x bar, y bar equal to x coordinate comes first, y coordinate comes next. And that's our 5 marks available.